also there are some values between, but we have a fiber volume fraction from 30% and 50%, resulting to different properties, mainly to be mentioned that we have a very high tensile modulus and tensile strength, as well as a flexural strength and flexural modulus. If you see on the right side, we have some different areas between a carbon fiber material and a glass fiber material. We'll just change it here, where we have the ratio between the specific strength and specific stiffness, and we are going to a level which there's not so many other materials, because mainly the combination of carbon fiber and PP are not so well established on the market yet. Some topics about the processability. I mentioned this, so we are providing the UD tape, but there are certain ways how to use the UD tapes. So as I mentioned, we are coming from a mother coil, 6 to 600 millimeter we are providing. We can slit the tapes to different widths, from ½ inch, 1 inch to more broader width. But also we have the option to chop the fibers for different other options. And one direction is, for example, we call from tape to sheet level. We can weave the tapes to create a laminate, a sheet. We can use a multi-axial sheets. It means we can also use plus minus 45 degrees, 0, 90 degrees as a layup, flexible as it is, not only full carbon, but also as a hybrid version. We can use the chopped fibers for the random sheets, or we can also use a small width to patching different PP-based materials which are on the market. Here's an example. It's an organo sheet, but it could be any PP-based material. For example, in a further processing methods, using the sheets in injection molding or thermoforming, using the random sheets, for example, for visible parts, or what I mentioned here is a combination. Here is a sandwich panel. Here it's a PP foam, but it could be also, for example, a PP honeycomb structure. Another direction is the tape placement, which means that we are placing the tapes by heating source in a most flexible way. Any orientation we would like to use for the load cases later on. It could be also used, for example, to make some pre-cuts also for the injection molding as a kind of local reinforcement. In the same technology, it could be another route to be as a tape winding. It means we're using the tapes also with a heating source, mainly laser heating source for the moment, to wind the tape in different thicknesses, different orientations of the angle. But we're not finished yet. Then with partners, we can, for example, bend the tube or also overmold the tube with plastic material for further functionalization. Some examples from our tape placement processors which are used our material. We developed with the AZL Aachen the ultra-fast consolidator machine, which wins a JEC award in 2019. We are using a robot-based tape placement system, for example, from AFPT. We're using other 2D tape placement machines which have been used already with Toughnecks, also the Fiber Forge machine, for example. But this is not limited. We have also other options to use it. Here's an overview to find out, okay, from tape to sheet, as I called. And what I want to show you here is what I mentioned already. It's not only a topic about a full carbon fiber material we can use, especially when we are more in the field of automotive and very cost-driven areas. We can combine our carbon material with any other external glass fiber sources. Either is it with a weaving style, we can combine it, or to make it as a multi-axial sheet where we're using the carbon fibers on the outside areas. As one example, what it could be, it's the first for the random sheets, for example. We're using the chopped Toughnecks, making some plates and then overmold it to functionalize. And we can have the choice also to change the design by changing the chip sizes from more broader chip sizes for bigger panels, but also smaller sizes for smaller panels, for example. We can also weave the tapes into a tool structure, for example. We can either keep it as a non-consolidated structure so that the customers can consolidate it later on and combine it, or either to use it as a laminate in a different thicknesses to use it then later on, for example, in back injection molding or for thermoforming the materials. One example for the from tape to sheet in terms of combination of carbon fiber and glass fiber. I want to show you just one use case here for today, as time is limited. Here we made different structures in a 3-point bending test. We used standard organosheet from external sources, which is a textile-based material, so it's a textile and then it's impregnated later on. And we have a certain level of specific flexural modulus for room temperature and for 85 degrees. Then we have the same structure. We put on one carbon fiber layer on the top and then down, so we have a kind of sandwich, which increased already the stiffness by 90% or even 123% with at 85 degree. And then we have, compared to a textile-based, let's say a stacked material, also a certain level, 2 millimeters, and just one layer carbon on the top and on the bottom. I should mention the carbon layer here is just 160 micron thick. So just with this thin carbon fiber layer, we could increase the stiffness by 152% in room temperature at an 85 degree. And we can for sure, and then this is the topic of balance out performance and cost, but we can increase the carbon fiber layers, for example, and so on to increase, obviously, the stiffness again. So I want to show you that it's not necessary to just think about a full carbon fiber solution, which for sure, from performance point of view, has the highest benefit, but also levels in between, like the hybrid versions, could have a huge benefit by lower cost increase. Coming more to an example of a tape placement, we used here from bumper fascia part, which we post-treated with certain levels of tape stripes. And the result was that with a number of different layers of the UD tape, we could reduce significantly the deflection. So we see on the right side, already with 2 layers, we could reduce 30% of thickness by using 2 layers, because then we have the same ratio as we would have a 2.5 millimeter without any tapes. Also, the weight is reduced. And this is something we have done, for example, here after the injection molding. So we use the tape placement, the local reinforcement after the part was already produced. For sure, we can also using the fixation of the UD tapes in the mold and then injecting the part. But here in this example, it was post-treatment. Another option for tape winding, we have a functionalization of pipe structures. Here we used a technology from Anybrit together with Inometer as tube manufacturer to functionalize a tube in a, let's say, robot-based injection molding machine. We see on the right side a small mold, which is just inject the thermoplastic material on the tube on the areas we will need. Here's just a demonstrator with different functionalizations. For sure, you can have any options, which kind of structure you would like to have on a tube later on. The last topic is some words about the engineering and simulation we have done here with our subsidiary ARC Engineering. First of all, a short update about what was the input of the material. So again, we used Toughnecks as cross-plying tapes using a solution by Van Wees to make a cross-plies in full carbon fiber with different angles, 90 degrees, 0 degree, plus minus 45 degree. And then using a cross-Maffei machine for producing a front bumper beam. The beams used here was for the full carbon fiber panel with a PP long glass fiber of 38%. We made also the same bumpers as a hybrid version, but for the simulation, we just tested the full carbon fiber version. So ARC engineering here used a new simulation method, a new shell model to predict the crash behavior. And we see on the right side two different simulation approaches, one without any delamination included in the simulation method, which results to not a good overlap. But with a new simulation method, they're using here internal shell model. We have a very good overlap between the testing, which is the dots, the black dots, and the red line with the delamination. So this was the beginning of the simulation, and afterwards we started to optimize the panel. For example, we used a new layup, changed the orientation of the tapes to predict the crash behavior, and therefore to integrate it also in a virtual vehicle evaluation between a original layup and the new layup, and therefore what is the conclusion is that we are able to optimize the part in the crash simulation area before it's needed to produce the part, which is also combined with higher costs, molding costs, so that we have here in the engineering, in the designing phase already the possibility to simulate with our material. ARC engineering is also present in our booth, so there's also colleagues available. So if there are questions about engineering and simulation, they will be happy to answer your questions as well. Coming to the summary, didn't have time to show all different use cases we are working on, but here is a kind of overview. We have different areas. We are working on different tailgate solutions with customers, outer panels for visual attractiveness, seats is one topic, cross-car beam in terms of winding structures, bumper fascia I showed already, bumper beam as well, and for sure underbody covers or door models. Each parts have different benefits there, or each properties they benefit from. But in the same structures, we're trying to combine different materials to have a hybrid material versions for every target. For sports, there are also routes we are developing. We are looking into its bicycle components on the one side for different levels, but also in sports equipment, combining, as I mentioned, other PP resource-based materials here, like a curved material, for example, or we're combining Toughnecks with a wood core. Here is an example for a skateboard. So there are very different options with the thermoplastic resin. Here, how to use the PP resin with the carbon fiber for any hybrid structures. And as a short outlook, we are for sure working on the sustainability route for our materials. So as an input, we are working on UD tape sheets or parts to be recycled, to be pre-cutted, and afterwards in a conversion process to recycle it in short fiber or long fiber pellets to reuse them in an injection molding process. Well, that's all for today in this short time. I would like to emphasize you to visit our booth. There are further information. You can receive this PDF here in the chat as well, and you just can click here on the names, as well as we have a lot of material uploaded our Toughnecks web special pages. My colleague, I think, already put as well in the link, but later on you can have also access from this PDF to those areas. Thank you very much, and I remain open for any questions. Okay. Okay, first question: how do you control the quality of products in factories? Well, there are two points. For sure, we to be clear, we are providing the UD tapes. So for sure, we have the quality control in our production of the UD tapes. continuously online for thickness variation to eliminate any gaps which are concluded so that the customer has the best quality he would like to have. When we are slitting the products, to have an accurate tolerance in the width. So this is everything we are doing for the UD tape production. When I show you the different processing methods, it is part of a, let's say, partnership, and therefore the partners will have, let's say, the use of any quality control. For sure, there's a standard level, but for the products I shown, then the partners are responsible for the quality. So, next question. So, question: what about UDPU-based fabrics for ballistics? We have a polyurethane material we are using just for our foaming agent. So for the composite materials, we just concentrate on thermoplastic resins, so on PP resins for the moment, because we're coming from huge footprint of polypropylene business. So polyurethane UD-based fabrics are not in our focus for the moment. How the tube winding works? Well, when you visit our booth, for example, there's just one special PDF about the tube winding as well. So there you can find some topics, and also you can visit the website for some videos. At least what you're doing is you have a heat source, like a laser, and you're winding the tape on a mandrel. And what you're doing is you consolidate layer by layer just in the area of the between the tube, the mandrel, and the new tape which is laying up. And this you're doing continuously, and you don't need any consolidation of the carbon fiber anymore. What you're doing is just the bonding between layer by layer with the PP resin. I think the best recommendation is here to visit the website. For example, there are a lot of videos about this, and this could give a clear view, I think. Okay, next question. We're using we developed the own sizing for the PP material. So we are working here with Formosa Plastics as a carbon fiber supplier, but this is a special treated carbon fiber with our own sizing development together. So it's not commercially available. When you speak exactly. Well, we're now in the study. So in the moment, we made some mechanical properties, but we're still waiting for some further studies. So at a certain point, we will publish this information, and also comparable to the virgin PP carbon fiber. But for the moment, we don't have the properties yet for publishing. Okay. I think one question here is a fast. This is based. We don't use the resizing, so the carbon fiber is applied with the PP based sizing already. So there's no epoxy based sizing on the fiber. How you to control the size gravity of the chopped materials or pellets? Yeah, well, this is some internal development, which is, yes, I cannot publish it here yet. So this is part of the development, and the colleagues in Japan are working on that field and have some solutions. But, well, this is a biggest challenge. Yes, this is for sure. Depending also on the further processing by press molding or continuous pressing, by double belt press, for example. We're working on that field, but I cannot publish here any information, unfortunately, about that. Okay, then just one question more. If UD tape is reinforced on the bumper cover, won't the surface and bumper cover sink? No, because what we have done here is to using the tape placement with laser source. So what you're doing is only you're heating up the surface and between the bumper cover and then the new UD tape. So you don't need to heat up the whole bumper cover, only really locally on that area. For sure, the pressing of the tape should be in accordance with the bumper thickness, but we don't see any sinking of the bumper cover. Okay, next question. What are the challenges in injection molding of well, challenges compared to what? It should be the question. Let's say usually, this is not the topic for our Tough-Nex tapes, but in general, the tapes is the fixation of the tapes in the injection molding. So how you're fixing the tapes or the laminates and the injection molding to have accurate time between preheating and injection molding. But this is not a challenge just for our Tough-Nex tapes. This is a general challenge. In terms of using our Tough-Nex tapes, it should be mentioned that we're working with the PP resin as mentioned, and PP is quite easy to handle. You don't have any humidity in the material. You don't have any high temperatures needed. So in terms of comparison to other UD tapes, the injection molding, back injection molding is quite easier to be handled with the Tough-Nex tapes. Is a PP tank the pre-preg? Definitely. The PP matrix is part of the business. So we are here, Tough-Nex is a product PP plus carbon fiber. So it's a combined. What is the behavior? Okay. We are working with a PP resin material. So melting temperature is 160 degrees. Pretty sure with 190 degrees, you don't have any PP resin anymore. So that is, for example, the reasons why we are not thinking about any aerospace applications, for example. 140 degrees, we haven't tested yet the material. So 85 degrees, and from the automotive area, it's the highest temperature we measured any properties. Yeah, as I said, 160 degrees is a melting point. 140 degrees is pretty sure area which it's not application range for a PP resin material. Okay, my last question. How about the GFPP combination? Go UD or fabric reinforced? I'm not sure if I understand right the question. So the GFPP material we use from external sources was either a fabric or UD layup. So you can, because this is not part of our business, so it's possible to use any fabric from as organosheet textile based from external source, but you can also use any UD from external sources and to make a layup by yourself. So at the end, both is possible. Okay, so I hope I could answer most of your questions. As I mentioned, please feel free to contact us at our booth if you have any further questions. I think my colleague also uploaded the PDF file. And well, thank you very much and enjoy the rest of the day and hopefully see you next year by physically. Okay, thank you very much. Bye-bye.